It's funny how this all happened that I landed up in Canada. I was working for a company in Johannesburg called Krachmal & Cohen Diamonds, and that was in 1974 and 75. I then moved on, and in 1994 I was asked to join a group of diamond polishers to cut large diamonds in Russia, in Moscow. And lo and behold, the team leader happened to be the son of the person I worked for in 1974 and 75. So I worked with Raymond Cohen over there, and some years passed, and in April of 1997 he called me up and he wanted to know how I was doing. I said, Raymond, you know, where do you park your car these days? Because we used to park in the same parking lot. And he said, no, I park my cars in Vancouver. And then he just spilled the beans. He said, listen, we have some large diamonds we want you to come and cut. And I said to him, Raymond, but why me? He said, well, we have our reasons. Well, it didn't take me long to make the decision. I always wanted to come to Canada, and that was a good opportunity. So we started the project, and by April it was concluded. And I thought, well, this is time for me to go back to where I came from, that is Johannesburg. And then they would have none of it. So listen, we want you to stay. We'll give you a third share in the company. We're going to buy diamonds in Belgium, buy in Brazil, and we would like you to stay on and lead the project, which I did. Towards the end of the year, they asked me to go and represent the company at a brainstorming session. The Northwest Territories government wanted to develop standards for the diamond industry because no standards existed. So eventually I became the technical lead on that, and a long story short, I ended up in Yellowknife, Northwest Territories, because the government said, listen, we don't want you to travel backwards and forwards, we'd like to have you full-time here. I was asked to write a training curriculum and also to build a training facility in Yellowknife, and that is what I did. And our company was responsible for the training delivery for a period of 6 years. And in 2004, the college won the Yves Landry Award for technical innovation. The time came to move on, and I thought, well, it's time to semi-retire. I was nearing the age of 60, and I came down to PA, bought a house down here with an idea that I will semi-retire and then still have something to do, you know, in the diamond play that's happening in Saskatchewan. So what we did is to decide, well, let's go straight into diamond processing, and that is what you see around us here.
No, I mean, my father is a genius when it comes to diamond cutting, and I think having grown up around it as a child, playing between the polishing benches and thinking every piece of dirt that you picked up was a piece of rough, and trying my hand at it when I was about 8 years old and quickly deciding that that's not for me. I think he's got a tremendous amount of knowledge and certainly a willingness to share that with the staff members.
What is a diamond? A diamond is crystallized form of carbon. Carbon under high pressure, under high temperature, would nucleate into a diamond. And that is where diamonds come from. They form in the mantle of the earth, and you find them in old areas of the earth's crust. It's called the cratonic regions, and that is where the diamonds are formed. And it's ancient volcanic eruptions that brought the diamonds to the surface. Okay, so this is a replica of octahedron diamond crystal. Now, as it is, we wouldn't like to cut it as one piece like that because it would make no sense. We need to have a flat facet to start off with, which is called the tail of the diamond. So we would draw a line on this and then we'd bisect it by laser or by a sawing machine. So that out of one diamond, we will be cutting two. There will be a major stone and a minor stone cut out of the same piece. We will maybe cut a princess cut or a radiant cut or maybe a cushion cut out of it. But we can even go around on it. It all depends on the stone. If there are problems in the points, you probably get a round profile, and otherwise we will go for an orthogonal shaped stone, and that one also could be an orthogonal shaped diamond. So from the one, we cut two. Diamonds could also look like this. This is a replica of the Premier Rose diamond, which was discovered in 1978 around. And this is the Premier Rose diamond. It came out of the Premier mine out of South Africa. And I had the privilege of working on part of this stone. My mentor David Duplessis was the guy who did the two major stones, and that became part of a collector's collection out of the United States, and it was purportedly worth $44 million, although the rough diamond was only purchased for $4.5 million at the time. So it is still probably one of the most beautiful polished sets of diamonds in the world, and it actually set a paradigm or a hallmark for what a well-cut diamond should look like, and that was done way back in 1978. There's nothing harder to cut diamond with. You can always use diamond to cut all the other gems, but you cannot cut there's nothing harder to cut diamond with, so you can only cut it with itself. So it brings into play the dynamics of the crystal. You have to know your crystal structure. This is the basic building block of a diamond. It's called the tetrahedral cluster. If you look inside there, you'll see 5 golf balls. And those golf balls coincide with the 4 points of the tetrahedral cluster, of the tetrahedron. Now the tetrahedron is the most basic shape that you can ever have. You cannot have anything with less than 4 faces, and that is the tetrahedron. And it is made up of 4 equilateral triangles. So diamond would really be classified as a body-centered tetrahedral cluster. That is just atomic structure. This does fit into the cubic system as well, though. So what we can do is just slide this into the cube, and you will notice that the 6 edges of the tetrahedron coincides with the 6 faces of the cube. So diamond, by definition, crystallizes in the cubic system, but there's a subsystem which I would call the tetrahedral cluster, which crystallizes in that system. Now, we've spoken about the hardness of a diamond. If we try and cut anywhere along these 6 faces, which we call the cube faces, it is totally impossible to cut the diamond coinciding with that. Similarly, if we were trying to polish parallel to the tetrahedral faces, it is totally impossible. The tetrahedron is a simplified form also of the octahedron. Now with the octa you have 8 faces. So you can just imagine a face on that side, a face here and there, and likewise for all the faces. Now those are the 8 areas on a diamond that you have to avoid, as well as these 6. That gives you 14 positions on a diamond that you absolutely need to avoid, otherwise you will not be able to cut it. So in between that, we can do the cutting. That is why when we design a diamond like the Sirius Star, we would start off in 3D, then we would take it to the next program, we would do a ray trace on it, and before we were even thinking of cutting the diamond. So we have to be happy that what we see here does work. There is proper facet definition. The variance between this facet and the next one, between this and that, is absolutely maximized on this crystal, and that's why we have excellent facet definition, and we know we're going to have a good light return on a diamond.
The more you play with your faceting, the more chances you have of moving the light around to different aspects. It's similar to a piece of an artwork, think of it that way. The more colors you put on a painting doesn't necessarily make it more beautiful. More facets on a diamond doesn't make it more brilliant. It's how you arrange the colors on the painting, it's how you arrange the facets that make either of them beautiful to the eye. Well, the Sirius Star is a patented cut, round, brilliant diamond. What he did, he took the way diamonds have been cut traditionally. Since 1919, it was the way they developed the ideal cut diamond, is what we know in the standard today. Now he's taken that and he's developed it with his own personal impression on it, as his own added facets to where he could improve the diamond.
Then we took it into another program called GemCAD, and we did a ray trace. We wanted to make sure that as the light enters the diamond, that none of the light leaks out, and all the light is returned back to the viewer. So as we can see here, it enters, it is that blue-purple color, and it enters the diamond, and as it hits the bottom here, it gets reflected to the other side, it gets reflected again, and it exits on the top, and now the angle changes. Look at this. So what happens once it exits the diamond, it disperses the color because it slows down the light, and the whole spectrum becomes visible to the naked eye, and we see the dispersed light coming off the diamond. Now we want to make sure there's no light leaking. In other words, every ray of light that enters the diamond has to exit again. Let's try over there. Okay, we're happy with that. Let's try the bottom facets. Again, the same thing. The light is exiting. As you can see, none of the light escapes out of the bottom of the stone. Everything gets reflected to the top or to the side of the crystal. So once we've assessed the ray trace on the stone, then we can go to the next step of actually polishing the diamond. So this is Chad Snyder. He's one of the first certified diamond cutters in Canada. He worked in Yellowknife, and he's joined us in April, and he's been here since. So what Chad is doing now is cutting a princess cut diamond, and that thing is about 3 carats, eh, Chad? Yeah.
Every Sirius star comes independently graded and verified by the American Gemological Laboratories, which is one of the more prestigious labs in the world. They tell you the whole history of the stone, the exact measurements, they tell you the color, the clarity, the cut weight, and they are the premium grader in the world. Their standards are extremely difficult to match.
When you get a diamond from American Gem Societies that is 000, which means there are 0 demerits on cut, there's 0 demerits on polish, 0 demerits on the proportions and the finish of the diamond, then you know you have an absolute fine diamond that it is just impeccable. You know, there's nothing to fault on that. So we have 4 that are registered, actually plus another 3, so it's 7, and we've just submitted another 4 for registration as well.
I get nervous every time there's talks of a new design in the pipeline because I know the amount of work that we are investing currently. We never want to be perceived as the factory in Saskatchewan, rather the studio that any of our customers have access to during office hours. They can pick up the phone and phone us. So certainly for us it's important that we as a family are available to the families that support us in the market. And I think indirectly the reason we choose to support the independent jewelers, because they are the ones who've established the jewelry market in North America.
Well, I'm 3rd generation here. Been growing up in the business from a very early age. This is what our family has done and enjoyed. This is kind of the backbone of Canada, is the family business, and it's important, and you can actually get a lot of expertise on a local level when you have somebody that's so ingrained in the business. So when I saw the Sirius star, it appealed to me. And what was best of all is it was local. It was cut in Saskatchewan, and that's very important. We have a lot of consumers that are interested in buying local.
A consumer will have an idea in their mind that they want a 1 carat diamond or a round cut or a princess cut. But if they're dealing with a diamond sales professional, that sales professional will guide them in the right direction.
I'll sit anyone down if they want to learn about diamonds. Really, you got to come down and trust your own eye. Your eye is your eye, and what you like will be different than what I like. So that's what the ultimate is. Learn to appreciate what appeals to you.
You know, and the more you work on diamonds and the deeper you study the subject of diamond crystallography, the greater respect you have for the product. It is just a passion, is all I can say. Some people would absolutely hate to sit in one spot and work, and others would just love it. And we have people here working for Embee Diamonds that have an absolute passion. It's an addiction. You just cannot let go of it. You have to create the next beautiful thing. And it's also wonderful to know that you're making people happy in the process. You know, I've seen many brides to be, you know, how their eyes light up when they see a beautiful diamond. You know, that's enormous satisfaction. that you get from that.